Hello and welcome everyone. This is the hotel and train demo. Okay, so with the demo, we've got three blockchains. So we've got travel agent CA blockchain, you've got a hotel blockchain, and you've got a train blockchain. So the hotel blockchain manages the reservations and payment for hotel rooms. The train blockchain manages a train and train seats and payment for train seats. And so the travel agent could book, or you could imagine another travel agency book, or people could even book directly as well. So in this scenario, a naive way of doing it would be what's shown in this slide, where you have a booking system trying to reserve a hotel room and a train seat and pay for it, and have all those contracts lockable. But if you have a second organization trying to do the same thing at the same time, then you'll fail due to hitting a lock. So how you could do this is you have essentially a router contract for the hotel and for the train, and have the individual rooms and seats in separate contracts, so that then when the second agency tries to book at the same time, they don't hit a lock on the room or the seat. However, they will with the ERC20 contract for the payment. So hence you need to change the method of using an ERC20 contract to also have essentially each item within an account is a lockable contract. And so the hotel might have, say, 5 slots which it could be paid into, but maybe the travel agency only needs 1 slot because it's only ever making 1 payment at a time. And but each of those slots for each account is a separate contract which is lockable. So in this way, you can have multiple payments, booking multiple rooms and multiple seats all at the same time. And so a key part of this technology is that cross-chain transaction, that where you're going from that booking contract into those 2 routing contracts. And so with our code, with our system, our technology, the Atomic Crosschain Transactions, what you're getting to is just those 2 lines of code down the bottom there, where you've got your cross-chain transaction in to book the hotel room. And so you're passing in the blockchain ID, the address of the contract to be called, and then the function to be called within that contract, and some parameters. And then with the train, again, similarly, you're passing in the blockchain ID, the contract, the function, and some parameters. And that, at an application level, is all you're needing to do. So it's a simple application developer interface. So those cross-chain transaction calls, we've implemented that as a precompile. And so the precompile is wrapped in this call here. Also, within those that hotel room booking router contract, you need to book a room. And so that you don't hit a locked contract, we've also got a precompile that checks whether you've got a locked contract or not. And so if it's locked, then you don't try and reserve that or check whether it's booked already. And as I said, within the ERC20 contract, rather than having a mapping of address to value, you've got an address to an array of addresses, and they're essentially slots which you could be paid into. And you've got a transfer function which, similar to a normal ERC20, has to include a check to see if it's locked, and is slightly more complicated to allow for multiple payment slots. So the demo. Now let's hope this works. All right, so we'll minimize that for a sec. Okay, so in this window here, I've got 3 Hyperledger Besus running on 3 separate blockchains. So we've just got 1 node per blockchain, which I know is a trivial case, but it's still, we've got 3 separate blockchains running. And one of these, blockchain 3, also acts as the hotel blockchain and as the coordination blockchain. So the coordination blockchain could be a separate blockchain, but in this instance, we're just having it using that chain, so we don't have to fire up 4 blockchains. So we start up the demo code, which talks to them. So now we'll start up in a sec. Okay, so we've got a few options. The first thing we'll do is deploy contracts. And so what it does is it deploys that ERC20 router contract on the hotel chain, and then it's a contract for each slot for the hotel to be paid into. And then it sets up the token supply for the hotel contract to be 1,000 tokens. It then sets up the hotel router contract and deploys contracts for each hotel room. And you'll note that you've got 3 hotel rooms. And then on the train blockchain, you're deploying your train your ERC20 router contract and setting up some payment slots for the train company. And then you're setting up the supply is 1,000 tokens, and you're setting up the train router contract and the individual seat contracts. And you'll note that you've got 4 train seats. And then we've displayed a bit of extra information about how many tokens are in each slot at the moment. And you can show some information about the contract by, say, looking at that. And you can see you've got your hotel, which has got 1,000 tokens, your train has got 20,000 tokens, and account 0x27, etc., is the travel agency. And for day number 3, which I specified, currently you've got no reservations, you've got 3 rooms available and 4 seats. So first thing to do is buy some tokens. So let's buy 20 hotel tokens. So we know that hotel rooms cost 13 tokens a day, and so 20 tokens is only going to get us a little bit more than 1 day. And let's buy, say, 100 train tokens. So train seats cost 5 tokens. All right, so let's do an atomic cross-chain transaction across them. So let's book for day number 3. So the demo that we've got at the moment is doing everything synchronously. Obviously we could set it up so that it was doing things asynchronously. So what you can see happening there is that you've probably because of that socket timeout, I think, is due to me running too many things on this one laptop. So don't get too worried about that. And so it's waiting for the cross-chain transaction to complete, and there's a timeout block number, which is in the terms of the coordination blockchain. And then by block number 41, so which is well before 46, the actual state was committed. And so it's already done. And then it's waiting for the contract on that originating blockchain to unlock. And then once it was unlocked, it then checked the booking status for that booking number. And you can see confirmation status true. So if we check the information for day 3, you can see that, I'll make this window a bit bigger. Yeah, you can see that we've booked seat 0 and room 0 for the amounts 13 and 5 with the same booking ID. So that's 1 booking done. And you can see that the balance now is only 7.95. So let's try and make another booking. So this should fail, shouldn't it? And so everything will pass except for that ERC20 transfer on the hotel chain, because you'll be trying to do the transfer, but you won't have enough coins. And as we can see, the cross-chain transaction fails, and the goes into the ignored state. So any provisional updates that were there in the train blockchain and in the travel agency blockchain, they will be discarded. And you can see that for that booking number, the confirmation status is false rather. And so if we have another look at the information, you can see that that booking did not go through for either the train or the hotel. So let's buy some more tokens. So let's buy 200 this time. So now we've got 295 tokens. Oops, did I I think I must have bought train tokens and not hotel tokens. Yes, that's more like it. All right, now we've got enough. So let's just quickly check how many tokens we've got. And yes, so now we've got 207 tokens for the hotel. So heaps of tokens. All right, so we'll make another reservation for day 3. And we can see that's committed. And after the contract unlocks, we can see that the confirmation status is true. And then we can make another reservation, day 3. And we have another confirmed booking. So looking at day 3, we now have 3 bookings. So we've got 1 seat available, but no more hotel rooms are available. So let's try and make another booking. So we should expect this to fail because you've got no rooms to book. But the train transaction on the train blockchain would have been right, but the hotel would have failed. And so, as you can see, the state is ignored. And so the confirmation status is false. So that didn't go through. So you can see that you've got atomic activity here. So either everything works or nothing works. And just to prove that things are still going good, let's book a day. Let's move forward a day and try and book for day 4. And that's committed. And it's unlocked. Confirmation status true. And show for day 4. And we can see that there's our reservation. So isn't that absolutely fantastic? Atomic cross-blockchain transactions. So now let's get back to the presentation. Sorry, just going to minimize this and try and get my slides to come back. There we go. All right. So we've got a white paper. We'll have this available on archive.org and on our sample code repo in the coming day or 2. So today is the 24th of February. So probably within a day or 2, we'll have an initial version out there. It's almost done. We just need to do a few things. And I think we'll be doing a few incremental improvements over the next week or 2. There is a YouTube video that you can watch on the Ethereum Engineering Group Meetup channel where I explain the underlying technology across about 35 minutes. The team who created this wonderful technology are shown here. And thank you to all of you. And the sample code is available in a public repo. That includes the hotel train example and some other demo code. And it will contain the white paper and the scripts that we saw to run multiple nodes of Besu all at once. We've also got a fork of Besu, and that contains the underlying code. The Besu that it was forked from was current as at mid-2017, either mid-September 2019. And the code also uses a fork of Web3J. And so that's got Solidity code, wrapper code generation to generate Java code to use Solidity contracts. And we've added stuff for doing cross-chain transactions. And there's a wrapper for some JSON RPC APIs that we've added as well. So any questions, please just send through to us and we'd be more than happy to answer. Thank you all for listening. Bye-bye.
in and can see.